Hello and welcome to the second video in the iNav 1.9 series. Now in this video we're going to continue to set this up and use this thing here. This is the Furious FPV F35 Lightning flight controller. It's designed to be a plug and play solution to pop into fixed wing aircraft. And although it's got all the cables on here and we are going to put it in the plane and do some basic setup in this video, first job is to download iNav Configurator. I'll put a link in the description and to install it onto your computer. Now in this video what we'll do is we'll get as far as doing the initial test on the flight controller, then we'll install it into the orbit wing. I'll show you some tips and tricks, and then we'll do the basic setup for both the receiver and the GPS. So first job is to click on connect, and luckily everything is working and we can see it. So if I move the board around, it should move on the screen as well. We can see here on the right hand side that a couple of things are red. That means that we have work to do to configure everything. And let me see what version of iNav is actually on this flight controller, because the first job is usually, if we can see it all working like this, to flash it. Now the fantastic news is it's running iNav 1.9, which is what we want to use here. So I don't have to go through the flashing routine. See the other iNav series on the channel to show how you would do that if it was running a different version, or if you're watching this and a later version of iNav is available. So let's do the basic settings here and just see if everything's going to work. So as I move the flight controller around, it's moving on the screen. That's great. See lots of little red X's on the right hand side showing that it isn't very happy, but it won't be yet because we haven't really done the configuration. First job here is going to be doing the accelerometer calibration. We'll probably end up doing it when it's installed in the fixed wing model, but for now we'll just do it on the desk. So what I'm going to do is I'm going to put the flight controller in each of the 6 orientations as per the diagram, and every time I do it I'm going to click on the button at the top and it's going to process it. Now it doesn't have to be in exactly the configuration at 90 degrees. It's got to be pretty close. The trick is don't move it. So if you find that there's a book around that you can prop it against, then that can help keep it still while you go through this process. This is teaching the flight controller what all the orientations feel like. And if you go through this process, just try and put it in any of the ones that are still remaining grey. Just put the flight controller in that orientation and just click on the button until you've got all 6 done. Once you've got all 6, then calibration is finished. Then that's all that stuff done and we can save and reboot everything. Now the other thing we can do here is also calibrate the magnetometer. We're probably not going to use the magnetometer in the flight controller the way it is at the moment. There's lots of big magnets inside this particular model, and the heading, which is what the magnetometer is giving us, the direction, can be calculated from the GPS bits and bobs anyway. So what you do is once you've clicked the button is you rotate the flight controller in all 3 axes, and eventually it will finish. Now if it's finished successfully, it should update the XYZ numbers. It didn't initially in this version of the interface. I had to save and reboot, and when I came back all those numbers had changed. This is just really to test the magnetometer is working. The model that I'm about to put it in with all those big magnets around inside the model is going to make the onboard magnetometer read incorrectly, so we're not going to bother with that. Okay, we've got lots of things turning green in the right hand side now. That's really good. So the accelerometer calibration's working, the magnetometer, there's all those numbers now populated, so we know that kind of worked. We will then select one of the presets, the closest one to the model that I've got here, and that will change some of the basic configuration settings and take some of the hard work out of the setup. This is one of the fab things about iNav, and one of the things that's unique about it compared to things like Betaflight and CleanFlight. Now the reason when I connect every time the little thing on the screen is rotating around is that is the magnetometer or compass just getting its bearing and kind of locking onto the direction. So if we go in configuration, we can see that we have a wing set up. So those numbers are things we need to take notice of, because that's where we're going to plug the servos and motors into. We can just scroll down here and see how it's set up. So we are going to use a serial receiver. We're going to be running S-Bus. I'm probably going to use something like an X4R. I've got loads of those kicking around that I used to use in the old days, but don't tend to get used to anything now. The FR Sky have the really small receivers. Okay, let's just continue doing the basic setup in here. and then make sure that we're okay. So we'll do the failsafe and all the mode settings in the next video, but I'm pretty happy at the moment that, you know what, this is all working. The accelerometer's calibrated okay, magnetometer's calibrated okay. We've told it that it's going to be in a fixed wing. This is good. Right, next thing we need to do then is go and install this thing into the orbit wing itself. Now the challenge I have here is that the orbit wing already has a flight stabilizer installed and this whacking X8R, which is what I had to use back in the day. Now I've removed the prop and I've removed the wings because that just makes it easier. I can actually get it on the desk to do the filming. So job one is to take the X8R out. That can go in my Tirana's case and I can use it on one of the other planes. Now this is actually sat on top of a piece of very thin balsa that's cut that covers the flight stabilizer and also covers the ESC at the back as well. Now I'm going to take the flight stabilizer out too. There's absolutely no point in me keeping electronics and weight inside a model that I'm not going to use. And also if I take that out and remove this piece of black T-shaped balsa wood, I also might be able to sink the flight controller below a little bit to maximize the space. Now to get this out, I slid a blade under the edges and just gently tried to prise it up. There wasn't tons of glue on here and eventually gave up. Just be really careful with this. I was trying to make sure I didn't slip and cut myself, because that's the usual kind of stuff I do when I'm doing this. But once it was off, it looked like that. So there's the stabilizer with the two servos and the throttle plugged in. So let me pull that stabilizer out. We're not going to use that at all. Now, of course, if we were using a bigger plane that had a lot more room, then installing the flight controller would be very simple indeed, particularly with the case that it's in. Now, I have to be a bit careful because I have to make sure that I can continue to get this carbon fiber spar through. So I potentially, let me just grab the flight controller. So these are the two things that I need to plug in, the receiver and the GPS. Now the flight controller, the front of it is opposite where the power cables come in, but mine isn't really going to fit like that. It needs to fit to the side, so the power cables are coming out to the left. Now we can install the flight controller any way we want and tell iNav that we've moved it around, but I think if I can put the flight controller in there, maybe cut some foam so it sits in that recess, that might work. The radio receiver can go above the ESC at the back and the antennas can come to the side. Not sure where the GPS could go, maybe on the shoulder. Don't really want to cut foam out of the shoulder. I mean, the GPS cable itself is really long. In fact, all the cables that are supplied with the F35 are really long. I'm probably going to cut the cable for the receiver quite short. So what I've done then is I've just marked out roughly the size of the flight controller. So now I'm just kind of press this in. I've made the hole slightly smaller than it needs to be, so it'll be a nice snug fit. The flight controller kind of fits like that. And if I slide in the spar, you should see actually is against the back of the flight controller, which does a couple of things really. One, keeps it nice and square inside, and also means that I'm not covering up any of the connections. Now the other thing I need to do is I'm going to try and keep this as neat as installed as possible. I'm a bit of a neat freak, so the power cables are going to be routed underneath and they can go to the ESC at the back. That will keep those out of the way, and I'll probably route the cable for the flight controller to the back too. I can also then plug the servos into the two outputs as per the diagram that was shown in iNav. So the servos are going to go into outputs 3 and 4, and the speed controller is going to go into output 1. Now I've done something a little bit wacky here. Now the whole idea of this flight controller is that it's plug and play, but because of the limited space inside the ZOHD orbit wing, it wasn't really designed to have a flight controller, which is why I'm having to cut things out of it to make everything fit. So what I've done is I've actually soldered the ESC power connections directly onto the flight controller. So I've taken the flight controller out of the case and soldered the ESC power directly onto it. Now it's a bit tricky, it's not really designed to do that because the output pins for the servos and the ESC are directly above where the solder connections are for the power, but with a little bit of care I've managed to do it without a problem. And that means I don't need a bulky connector going to my ESC, and the slightly thinner wires for the ESC that's in this model will also make the installation a bit easier too. So here's what it looks like when that soldering's all together. One last thing while I've got it out of its case, there is only one blob of solder in here that you can change for the way that the F35 works, and that's whether or not you're using the internal or the external BEC. Now this is all about how the power works and whether or not you're asking the flight controller to provide the 5 volts that's going to run the servos, or you're going to use the 5 volts that's coming in from the battery eliminator circuit that's part of the speed controller running the motor to power the servos. Now, as the BEC in this model has been working perfectly, I'm going to keep it as its default and let any 5 volt supply that's on board the flight controller take care of things like the camera and stuff as well. And that way, because I know that the BEC that's part of the model already is more than capable of handling everything, that's going to work. And I also don't need to panic about that BEC that's part of the speed controller also having enough amperage to run the flight controller, because the flight controller is going to power itself. Again, very smart design and make it easy to install. So here's what it looks like with the ESC all soldered on. That's an awful lot neater, and it's gonna fit in really nicely into that spot. I'm going to use double-sided tape to hold it into position, and then all I need to do is plug in the wire from the ESC and the 2 servos as per that diagram in iNav. So now that that's all installed together, I've made the ends off for the X4R as well, and I've also plugged the GPS back into the flight controller. The GPS, I've decided what I'm going to do, I'm going to mount it in the canopy that snaps onto the ZOHD orbit wing. I could have put it out on the wing, but I like the way of actually being able to remove the wings for transport. It makes it a much more versatile wing to take into remoter places. And if I put it in the middle of the canopy, it should be far enough away from any FPV antennas and also the antennas for the X4R in the back. Now, the way I've installed it, I've then cut a couple of very shallow slits into each side in front of the X4R and run the antennas out, so they're popping out each side of the main body of the model, and they're out the way of the canopy when it closes too. Right, that is the physical installation done. That wasn't too tricky. Next thing we need to do then is run into iNav and do the port configuration. Now, the manual for this thing is really good. It talks about all the settings that you need to do for both the GPS and also whichever receiver you're sorted out. By default, interestingly, it's set for TBS crossfire stuff. Now, I'm not going to be using that. I need to set it up so that it's going to run with S-Bus and smart port telemetry, because that's what I've connected it to. Now, the cable that came with the F35 was designed for an XSR, and if I'd have used an XSR, I could have just plugged the cable straight into that receiver and not had to mess around making the end off. But as I was cutting the cable short anyway, as I said, I've got loads of these X4R things knocking about. I might as well use one up for this model, give me a chance to reuse one in a model that I'm actually going to fly. So the first thing we need to do is go into the ports tab. We need to make sure that UART3 is set as a serial receiver, and we'll also turn on UART6 as smart port. That will mean that it's listening for S-Bus on the right port, and it's also going to be sending out the telemetry via UART6 as well. We're going to have to then go into the configuration tab, scroll down and select a serial based receiver and make sure we're on S-Bus. Once that's working, then go into the receiver tab and make sure that you can see all the controls working. Make sure that they don't go below or above 1000 to 2000, and that they also settle in the middle position as 1500. Now, the radio setup that I've used here is pretty standard stuff. I've got the standard 4 controls. You don't do any mixing or anything clever on your radio at all. All of that mixing and smart stuff is actually done by iNav, and I've also added an extra 2 or 3 channels. One of those will be to select the modes, one of them will be to select arming, and another one will be kind of the oh dear switch, which will initiate a GPS return to home and will be also used for failsafe detection too. The nice thing about the F35 is that it does power the receiver when you plug it into the USB cable, so you don't have to apply main power to do your binding process. That's really nice. Again, at this point with your setup, make sure that you've not put any props on anything and keep it nice and safe. None of the PWM outputs on the flight controller will be active until we finish the configuration and formally turn those on, so that nothing should be moving and nothing should start up, but it's better to be safe than sorry. Next thing we need to do then is we need to configure the GPS that we've got plugged in this thing now. So we're going to go into the ports tab again, and we're going to configure UART2 as GPS and select 57600 baud as the speed. Again, save that, and then go into the configuration tab, go down and turn on the GPS for navigation and telemetry stuff. Now what will probably happen is, unless you've got the main battery attached, then the GPS will try and auto configure and fail, and then you'll have the red icon at the top. Don't worry about that. When you power it with the main battery power, the 5 volts from the flight controller will both power and configure the GPS module, and it will all work. So the only last thing I'm going to do here is I'm going to probably disable the magnetometer. As I talked about at the beginning, you don't need a magnetometer for a plane in iNav. It can get the direction of the plane from the moment-to-moment changes in the GPS location, and I find that with planes with lots of magnets like the Orbit, it just plays havoc with it anyway, so I'm just going to turn that off. So that is an awful lot of the setup done. So in this video, we've tested that the flight controller was okay before we plugged or anything into it and started snipping wires off. We've installed the flight controller into the model, and we've also attached the receiver and the GPS. Again, you didn't have to do all these extra little tweaks, cutting cables and soldering that I've done here. It's designed to be plug and play and a piece of cake to install into a model. It's just that I'm a neat freak and it's a little bit tight inside this particular model as it's not designed for a flight controller. We've set up the basics in iNav. We've done the port setting for both the receiver, make sure that's all working. We've done the GPS settings, and we've also done one last thing, board orientation. Now the front, as I talked about, of the flight controller is the bit that's opposite the pins. So the pins would normally come out the back of the flight controller. It doesn't fit in the Orbit that way. So I had to go and change the board orientation to be yaw of 270 degrees. Again, that's all covered in the manual, and then save and reboot. And then once I lifted the nose of the plane, the little virtual box moved in the right way in iNav 2. So we've done a lot in this video, but we've got some final config bits to do in the next video. So join me in that one where we'll configure all of the FPV pieces. We'll set up the modes and the failsafe. Then we'll finally, once we've got all that happy, we'll click the enable PWM outputs, and then the servos and speed controller will become live. Then we can do our servo settings, calibrate the ESC, and maybe take it for our first test flight. So join me in that next video in the series where we'll continue the setup. If you found that video useful or like the content, then please hit the like and subscribe button down below. If you want to go the extra step, you can become a Patreon of the Painless 360 channel and help provide support for what I do here. All the videos created here are put into playlists, so if you're interested in a particular topic, have a look at the playlist, and they all are organised in there to make them easier to use. If you're not sure if there's a video for your particular problem or topic you want to know more about, then add Painless 360 to the Google search term that you're interested in, and that should find the video, article or content about the particular thing that you're interested in having a look at.